Good morning. Today we'll discuss about the phase equilibrium. This is included in the engineering chemistry, phase equilibrium. So, first we'll discuss what is phase. What is phase? Okay. Phase, suppose we'll think about the stages of life. One is young age and other is old age. Young age and old age. So we can think young and old is the two phases of life. Two phases of life. Similarly, in chemistry also we'll use the word phase. So whatever the substances we encountered in our life, it has some kind of phase. So we'll discuss how to recognize the phase of a given substance. So one by one we'll discuss. So if we'll categorize the substance existing in the world, it is of three types. One is solid, other is liquid, and the third is the gas. If we define the definition of phase, definition of phase, what will be? The definition of phase is physically distinct and mechanically separable, mechanically separable and homogeneous substance. So physically distinct, mechanically separable and homogeneous. Physically distinct means we can segregate the substances. Mechanically separable and homogeneous. Homogeneous we can think it's a uniform mixture. Okay. So the definition of phase will be clear only when we will discuss different substances. So let's take the gaseous phase. So in order to decide the phases of gases, there is one rule. Always, whatever may be the number of gases, phase will always be one. Phase will be one. Suppose we are present in a room. In the room there are so many gases: hydrogen, nitrogen, oxygens, mixture of gases. But we cannot make the distinction between the number of gases present in a room. So we cannot define any gas as a physically distinct. Also, we cannot separate the mixture of gases. Not possible to separate. So this is mechanical separable is not possible, and it's homogeneous. Though several number of gases are present inside the room, but it seems to be uniform. We are not able to distinguish between the number of gases present. So whenever the gases will be present, we'll think the phase will be one. So in the case of gas, always the phase will be one. But in case of solid, we have to look into the number of solids very vigilantly. Okay. Suppose let's take an example. Calcium carbonate undergo decomposition to form calcium oxide and carbon dioxide gas. Here calcium oxide is solid and calcium carbonate is solid, carbon dioxide is gases. If we will see this equation, here the number of gases is 1. So for this CO2 the phase is 1, and there are two numbers of solids are present. One is calcium oxide and the other is calcium carbonate. These two molecules are totally different. Here calcium oxide constitutes made up of calcium and oxygen, whereas the calcium carbonate is made of three types of atom: calcium, carbon and three oxygens. So these are two different solids. So for this calcium oxide phase is 1 and here phase is 1. So in total, in the chemical reaction, total number of phase will be 3. Phase will be 3. So let's consider another example. Ammonium chloride. Ammonium chloride, on heating, it gives two type of gas, ammonia gas and HCl gas. Ammonium chloride is a solid. So in these equations we are getting two gases as a product. So one is ammonia, other is hydrochloric, fuming hydrochloric acid. So for the two gases we will consider only one phase, because whenever the number of gases will be present, the phase will be 1. So for these two gas, phase is 1, and for ammonium chloride solid, phase is 1. So total number of phase will be 2. Two number of phase will be present. Now, so whenever the solids will be present, we have to recognize the phase very carefully. Suppose the mixture of two metals. Suppose I am mixing iron powder plus copper turning. So this is the mixture of iron powder and copper turning. So what will be the number of phase? Here the number of phase will be 2, because we can segregate, we can separate the iron powder from the copper turnings by some mechanical means. But when we will melt the iron and copper, it will form an alloy. At that time, we cannot separate iron from copper, because here two metals are uniformly mixed to form the alloy. So we cannot say the mixture of iron and copper alloy is two phase. Here the number of phase will be 1. You see the difference. When we are mixing iron powder and copper turning, these are two different homogeneous mixture, so the number of phase will be 2. But when we are heating iron powder and copper turning with high temperature, at this time alloy is formed, so here the number of phase will be 1. So we have to be very careful whenever we are deciding the number of phase in case of solid. The third one is the liquids. The liquid for deciding the number of phase in liquid, we have to be very careful. Always for that we have to know the nature of the liquid. If we will decide the nature of the liquid on the basis of polar and non-polar, then we can easily distinguish between the number of phase. So what is polar liquid and non-polar liquid? Let's take an example. Water molecule, H2O. This is the structure of water molecule. So if we will see here, oxygen atom is present and hydrogen atom is present. Oxygen is highly electronegative elements, so it has the more capacity to attract the shared pair of electron towards itself. So it will gain partial negative charge and hydrogen will gain partial positive charge. Here also hydrogen gain partial positive charge. So what we are observing in the water molecules, we are observing the development of fall in the water molecules. So we can say water is the polar liquid. But if we will see some hydrocarbons, for example hexane molecules, it contain 6 carbon atom, 1 2 3 4 5 6. So it is surrounded by hydrogen atoms. So is this molecule polar or non-polar? You think if we will see the electronegativity value of carbon and hydrogen, they are almost same. So the shared pair of each electron between carbon and hydrogen remains in the middle. So there is no polarization, there is no development of charge between carbon and hydrogen. So we can say N-hexane is a non-polar liquid. We can say hexane is a non-polar liquid. So when we do the mixture of water and n-hexane, it will never form miscible liquids. These are two immiscible liquid. Suppose this is the separating funnel, and in the separating funnel I am putting two liquid, water and n-hexane, and after vigorous sacking, when I'll kept the separating funnel for some time, I'll see the two layers of liquid. The bottom layer will be our water and the upper layer will be the n-hexane. Here two liquids are not able to mix with each other. Why? The nature of the two liquids are very different. Here water is a polar solvent, polar liquid, and hexane is the non-polar liquid. So they are not able to form the uniform mixture. So here the number of phases will be 2. Here the number of phases will be 2. But instead of n-hexane, if we will add methanol molecule or ethanol molecule, C2H5OH ethanol molecule, they will form the uniform mixture with the water. At the time we cannot able to segregate the differentiate between the two liquids. They will completely mix with one another by forming the hydrogen bonding. So at that time the mixture of ethanol and water, at the time we will say the phase is 1. So I will conclude the gist of this page. So whenever we will see the gases, the phases will be always 1, and in case of solid we have to carefully look into the solids, number of solids. If the solids are able to separable, then according to the phase will be decided, and in case of alloy the phase will be 1, whatever may be the number of metals forming the alloy. And in case of liquid we will be very careful by observing the nature of the liquid, whether the liquids are polar and non-polar. We have to put the rule of chemistry, like dissolves like. If two polar liquids will be present, then it will form a single phase. If two non-polar liquids will be present, it will form the single phase. But if we will mix between the polar and non-polar, the phase will be different. That's all for this class. In the next class we will discuss about the components. Phase equilibrium, we will decide the degree of freedom by knowing the number of phases, the components. So in the next class we will discuss about the components. Okay.